In this session, let's discuss about another operation that can be performed on arrays, that is searching. Searching an array means to find a particular element in the array. That is, if you want to find whether an element is present in the array or not, you can use this operation. This operation can also be used to find the position where the element that is being searched is present. According to the way searching is being performed, there are two different searching techniques. One is linear search. Linear search is also known as sequential search, and the second technique is binary search. So in this session, we will discuss only about linear search. Now, let us try to understand about linear search. Linear search sequentially checks each element of the list for the target value until a match is found or until all the elements have been searched. That is, if you are searching for an element that is present in an array, then this method applies a searching technique as follows. That is, first of all, it will traverse the array beginning from the first element, and it will check with every element in the array to the search. It tries to find a match with the searching element beginning from the first element in the array. That is, it will take the first element in the array and compares it with the value that is being searched. If it matches, then it stops there and returns the position of that particular value. Otherwise, it moves to the next position, that is second element in the array. Again, this comparison process is continued until a value or a match is being found. If a match is not found until you have completed all the elements in the array, then it means that the element is not present in the array. Then it will return a message that is element is not present in the array. So let us understand this with the help of an example. So here you can see the linear search technique and how it works. So the first step is, it will begin with the first element in the array. That is, here in this example, we are trying to search the element present in the array. That is, here the searching element to be searched is 33. So, starting from the first element, it checks whether it is equal to 33 or not. That is, here first element is 10. So, 10 is compared with 33, and here you have not found a match. Then it moves to the next one, that is here that is 14. 14 also does not comes equal to 33. Then it moves to the third element, 19. 19 also does not match with 33. So it moves to the next position, that is 26. And this process is continued until it reaches this particular position, that is 33. So here we can see that when it comes at the position 7, it finds a match with the element that is being searched. Then the linear search technique will be stopped here and it will return the position of the array element present there. That is, here the array element 33 is present at the location number 7 or index 7. So the position of the element, that is 33, is at 7th position. So this will be the result of this particular example. And now let us consider another case, that is, if the element that is being searched is not present in the array. Let's take an example. So let us see 2. The element that is being searched is 2. So we can see that here no elements are 2. So, but the algorithm will continue or start from the first element itself. That is, it will check this 2 with 10, and we can say that it does not equal to 2. 10 is not equal to 2. Then it moves to the next position. Here it is 14. 14 also does not match with 2. So it moves to the next location, 19. 19 also doesn't match. So this process will be continued with all the elements present in the array, and finally it reaches the end of the array. That is, it reaches the last element in the array here the last element is 44. So 44 also is not equal to 2. So it means that we have not found any element that we have searched for. So the conclusion is that the element is not present in the array. So it can be displayed with the help of a message, that is the element is not present in the array. So this is how linear search algorithm operates. Now let us see the algorithm for this method. So here you can see the algorithm. So here we are operating on the data structure A, that is the array, and value x. Value x means this is the element that is being searched. X is storing the value of the element that is being searched. Let's take an example here. So let's say we have an array. First element is 10, second element is 2, third element is 3, and fourth element is 5. Let's take this as an array of size 4, which consists of 4 different elements, that is 10, 2, 3 and 5. And let's represent the index value of this array using the variable I, and let's say it starts with the index 1, that is 1, 2, 3 and 4 represents the indices of this array. Now let's work on the algorithm. So in step 2, I is initialized with the value 1, that is we are beginning with the first element in the array. Now moving on to step 3, if I greater than n, then go to step 8. So here n represents the number of elements or size of the array. So according to this example, the value of n will be 4. So while checking this condition, i's value is 1 here and I greater than n, that is 1 greater than 1 greater than 4. So it is a false statement. So we'll move on to the next step, that is step number 4. Here if a of I is equal to x, here also a comparison is being performed. Here it checks for a of I, that is whether it is equal to x or not. Here x is, let's take x value as 2. That is the element being searched is 2. So here first of all i's value is 1. So we are at the position number 1. We are at the first element in the array and we are checking for a of I is equal to x or not. That is 10 is equal to 2. Here x value is 2. So we are checking whether 10 is equal to 2 or not. So we can find that 10 is not equal to 4. That is 10 is not equal to 4. So if it is true, then go to step number 7. So it is not true, then what will be the next step? The next step will be step number 5. So here it is given that set I to I plus 1. That is we have not found a match here. So what we need to do is to move to the next position. That is, in order to move to the next position, here index value set as I plus 1. So I is incremented by 1, then I value will be 1 plus 1, that is equal to 2. So now we will be at the second element in the array. So here you can see that again after step 5, in step 6 it is mentioned that go to step number 3. So again it will go to step number 3, that is I greater than, checks whether I greater than n. Now I value is 2. So if we are comparing this expression, 2 greater than 4, 2 is not greater than 4, then it will move to step number 4. Here you have a of I value is a of 2 is 2 here. So 2 is equal to x. X is again we have not changed x value. So x is now 2 itself. So here a of I is also 2, x is also 2. So here we will find a match. When we find a match, it is said that go to step number 7. So step number 7 is doing print element x found at index I and go to step number 9. That is print element x is found at index I. Here x value is 2. Then it will print that 2 is found at index I. Now index value, what was the index here? 2 was the index. So element 2 is found at index 2. Then it will terminate the program. That is what is being happening here. And if we are taking another element, that is say for example, we can take the element to be searched as 1. Let's search the element 1 here. So if it was 1, then this algorithm will be continuing until the last element. How it will be performing? I is greater than or equal to, initial case I will be beginning with 1, and if I is greater than n, it will go to step 8. That is print that element is not found. So until it reaches this condition, until it becomes I equal to n, this process will be continued. That is, it will search the first element and compares the result with a of I, first element, then whether it is equal to 1 or not. So in the first case, a of I is 10 and it will be matching, it will be comparing it with the element 1. So if 10 is equal to 1, we can see that 10 is not equal to 1, then it will go to next step, that is I is equal to I plus 1. Then it will move to the second element in the array, that is 2. Again here condition will not be true, so it will move to the step number 4. Then here a of I is equal to 2. 2 is again compared with element 1. Then 2 is equal to 1. It is checking for 2 is equal to 1 or not. Here it doesn't match. Then again I will be incremented and I's value will be 3, and it will again compare the value 1 with the element present at the third position, that is 3. It also doesn't match. Then the I value will be incremented by 1. So I value will become 4 in this case, and it again this will be compared with 1. So here also we can see that it is not matching with the value 1. Then again one more time I will be incremented. Okay, then I becomes 5. I becomes 5. I value will be becoming 5. And at this position we can find that the condition here becomes false. That is 5 greater than 4 is true. When 5 greater than 4 is true, then here it is given that go to step number 8. So here it will move to the second step number 8, and here it is displayed that element is not found. So in this case we are searching for an element that is not present in the array. In that case the result will be element not found. So this is how this algorithm operates. If an element is present in the array, it will return the position of that element in the array. Otherwise, if it is not present, then it will gives a message that element is not found. Okay. Now we can see the time complexity of this algorithm. So here time complexity can be considered for the best case and worst case. Best case is that the first element matches with the element to be searched. That is, we are searching the first element in the array itself. In that case, it can be considered as the best case, and here the best case complexity will be O of 1. That is, only we have to compare the first element with the element to be searched. In that case, the time complexity will be big O of n. And in worst case, what will be the worst case? The worst case is that the element that is being searched is present at the end of the array. The last element in the array is being searched. In that case, we have to traverse the array from the first element to the last element. So there may be n elements in the array. If there are n elements in the array, then in worst case, there need to be n comparisons. So that is why in worst why the time complexity of worst case is given as big O of n. So this is the time complexity for linear search in arrays. So in the next session, we'll understand binary search algorithm. So thank you.